Okay, so I mean, the time is not too abundant. I can't just spoil this question for you because I need you to have some idea that this question is not as hard as you think it is, right? I mean, we kind of did some difficult problems for homework sets and stuff. You might think, hey, IMO is going to be this monster, but this is the last question, okay? So, um, hopefully you understand that there's nothing really to be afraid of. But I might not have time completely to let you solve all of it. So, but I do think some of the steps everyone will have pretty similar ideas for. So maybe we can kind of do a bit of each, okay? And in the fork, if there's a fork in the road, um, I'll kind of make a choice that'll let us go in a different path than Monday, okay? Okay, so does anyone have something we can just start off with? Maybe I'll check up on you every few minutes, but there's some obvious stuff right away, yeah? Is that Finn? Oh, the polls thing works now.
Oh, nice.
Yes, last digit 0, okay? Because it's to be divisible by 10, yeah? So, I think you should write it in full, like, short sentences to last digit 0, um, looks like it's equivalent to, div by 10, right? Okay, so let me just write up two really obvious things. Last digit 0 and fifth digit is either 0 or 5, but 0 is taken, right?
可以是1吧，可以是3，对吧？可以是7，也可以是9，对吧？都可以。
Nathan, you're not muted.
Hmm. Oh, okay, good. Alternating odd and even. So um, so eventh digits, whatever this means. Even place digits are even. Because that's what being divisible by an even number means. It's at least it's even. But that also means there's not enough even numbers to go around for the odd digits. So that means the odd digits are odd. Okay, I'm sure. I think at some point we're reaching like a 1 mark. We're getting about we're almost up to the point to get 1 mark for this question. Okay, so fourth digit is 2 or 6. Eighth digit is also 2 or 6. I'll write it the other way because once Yeah, 2nd and 6th you mean 4 or 8, yeah. Okay, you guys are racing along, so that's good. So basically, divisibility by 4 and 8. So divisibility by 4, you only need to look at the last 2 digits, right? But you know that the second last digit, the 10th digit's odd. So the last digit, so divide by 4 with 10's digit odd. Gives units digit either 2 or 6, right? And so that applies to the divisibility by 8 as well. Because in that case you look at the last 3 digits, but the hundredths digit is divisible by 8 because it's even, yeah. So actually we've eliminated. Oh, okay, good. So the 9th digit can be anything. Yes. So it's anything in the sense that if it satisfies all the other conditions, the 9th digit divisibility by 9 thing has no other conditions, right? So it's one of those nice observations that might not make its way to the final answer as much, but it's worth noting down. Okay. So and then divisibility by 8 just reduces to divisibility by 4 given the other conditions. And I guess the only real thing that we haven't dealt with is divisibility by 3, right? Yeah, so here is so like these are all very nice observations, and one way to sort of quantify it is that like at the beginning you have like 10 factorial possible numbers, and now you have like once you put the 0 down, you only have like you've reduced it by a factor of 10. Okay. Put the 5 down, reduced it by a factor of 9. So like the number of possibilities is decreasing sort of exponentially with these observations. So it's by an order of magnitude every time. Okay, so um okay, so maybe here I should mention, and then obviously the divisibility by 7 is kind of the one that's a bit random. We can't necessarily deal with that as easily as the others. Okay, so so maybe one of the questions you might be considering is like when is it time to just kind of like bash out the remaining possibilities? Like when is it time to just kind of like you're done with these general observations and you need to just compute numbers? or case bash. And sort of like maybe like a vague answer to that question is when the cases sort of are strong, they're sort of strong enough to not branch out further. That's at least a good sign that you can get it in like a short time. Obviously, in real maths, the cases could branch on for a long time, but you can still get there in the end with lots of perseverance, and that's how a lot of research happens. But but how much the cases branch out will ultimately be how difficult the question remains, right? Okay, so let me just describe how the fork in the road goes. So on Monday, okay. So if you want to look at, you can try this yourself, or um actually maybe you can think about a bit about how the cases break up for a second before I spoil it completely. Oh, actually, I think Nathan already said something as well. Did you? Yeah, so I think it's a little bit like that. So like on Monday, for example, so I was considering because divisibility by 3 is just a digit sum, right? Say you can assume these 3 digits add to something divisible by 3. um, so one possibility you can take is the 6, because that'll keep this digit sum divisible by 3, right? But if you take 6, 5 will make the digit sum have remainder 2, right? So to get it back to divisible by 3, you'll need to use the 4. Okay. But once you pick the 6 and the 4, the 8 and the 2 are forced in the other spots. So that's strong enough to really get the cases down, okay? um so that's what we did on Monday. So what I want to do today is go for the other case. Yeah? And this way you can look at both if you want. So the other case is, so instead of preserving this divisible by 3, we disrupt it, yeah? So we stop it from being divisible by 3. Okay, so can you see what happens there? So let's assume 2 is the 4th digit. Yeah, that's basically what the case is. Hmm. So this might be a promising way to break up cases, because once you pick 2 to be the 4th digit, it tells you how to pick the other 4 choices, right? So if you have this 5 and the 2, it'll have a remainder of 1, right? So then you'll be forced to pick the 8, and then you'll be forced to pick the 6 and the 4 because the others are taken now, right? Can we get a bit of a microphone check? People still here?
Yep.
Yes.
It's actually easier for me to listen. Oh, nice. It's actually easier for me to listen than to read the chat if I'm already writing stuff. Okay. So that's a good promising case breakup, because so maybe the case 2 you can look at, assume, so obviously there's only 2 cases here. Assume 6 is the 4th digit. And this, hopefully you know how to look up the recordings, yeah? But I mean, ideally you just do it yourself, and then you can look up the recordings in case I give you some new ideas. So the recordings are on a playlist in the notes section of so it's on YouTube as unlisted, and it's linked on the notes section of Discord. But today we focus on case 1, and it's essentially spoiling the other case as well, I think. Okay, what to do from here?
Look at the divide by 8.
Divide by 8?
Yes, since we know that the 4th, 5th, and 6th number is 258.
Yeah, so it automatically be divisible by 8 by the way we came to those possibilities. Yeah, because the 200 is divisible by 8, and wait, hold on. Is this not divisible by 8? Oh no, that's divisibility by that's not divisibility by 8. Yeah, so it's divisibility by 8 happens on for the first 8 digits. Yeah, so it'd be for here. Yeah, but the point is divisibility by 8 and all the even numbers are not going to come up again. Does that make sense? Like we've completely exhausted those conditions to get to get those 4 numbers, you know? Okay, so let's summarize what we have. So we have not zoomed in enough before. So we have space 4, space 2, 5, 8, space 6, space 0. So we don't even really need to look at the number. Like we don't even need to look at the number past this point, right? Because all the conditions there are already met. And we have, so this is just some basic organization. So we just have the odd numbers left, right? 1, 3, 7, 9. And we just basically have to place 3 of them . 3 of them so the only 2 conditions we haven't used is that this is divisible by 3 and this is divisible by 7. So I'll give you a little bit of time to ponder this. I think it's good to think about this and see if you feel comfortable with this. It's obviously going to look easy when I tell you what it is, but okay, so Leon made some nice observation. He said, 4 can only go with a 1 and a 7. It can't go with like 3, because 1 and 7 are both 1, remainder 1 when you divide by 3. And 4 is also remainder 1. If you're going to use a 3 or a 9, you need something that's 2, remainder 3, remainder 2. So you have that it's either 7, 1 or 1, 7. Is that right? Okay. So that's a very strong breakdown of cases again. Anyone want to suggest what to do next?
Look at like divisibility by 7.
Yeah. So there's a few ways to do this. So we can just focus on what 7, 4, 1, 2, 5, 8, 0. So that's the contribution without the this last digit here. We can figure this out mod 7, and we could also figure 1, 4, 7, 2, 5, 8, 0, mod 7. Yeah. Oh, so wait, is divisibility by 8 forcing that last digit to be? So did I say something slightly inaccurate before? So divisibility by 8 now doesn't. So if the 1 and the 7 are taken, divisibility by 8 can only go with, so 96 for sure, and 36 is not divisible by 8. Oh, okay. Well, this is quite a revelation. Okay, so I don't know who suggested that. The person on the whiteboard. Very good. So this has to be a 9 then. So this case is actually much easier than the other case. 9. So it has to be a 9 because the 36 is not divisible by 8. Yeah. Okay, so then we just have to consider, instead of having a 0 here, we can have a 9 here. So it actually just suffices to calculate that well, these things are mod 7, right? And then we've resolved this case. Actually, I'm suspecting this is Johnson for some reason. Okay, so do you know how to figure this out, mod 7? Get a bit of a microphone check. People hear?
Yeah.
Yeah,
Excellent.
Yes.
it leaves 2 mod 7.
Oh, there's a yes that sounds like Kevin, but I'm sure he's not here. Okay, so you could do this. This can be done straight up, modular arithmetic. You can kind of remember the div by 7 rule, but that's really just modular arithmetic. So it looks like Leon has done one of them, so let's just do one of them. The bottom one looks easier, so I'll do the bottom one, okay? I'll do the bottom one first. So I know 14 is a multiple of 7, 7 is a multiple of 7, so it's actually, this is just equal to 2, 5, 8, 9. And I know 21 is a multiple of 7. See, doing mod the long way is really just it's just doing long division without writing out the answer, right? So you get like 4, 8, 9, and then 490 is a multiple of 7, so this has got remainder 6, yeah? This is equal to 6. If you remember the divisibility rules, which is really just saying 10 to the 6 is equal to 1, and 10 to the 3 is equal to minus 1 mod 7, you get that this is equal to, so it's really 1, so you can sort of do a digit sum, but you do it 3 digits at a time. So it's 1 minus 472 plus 589, yeah? So you only ever really have to deal with like 3 or 4 digit numbers. So you minus that, you get 117 plus 1. And you can do this a lot of ways. I mean, 105 is a multiple of 7, so you get 12 here plus 1. And that should be remainder of 6. Okay, let's do this one both ways as well. You can take it mod 7 directly, so 7 becomes 0. You get 4, 1, 2, 5, 8, 9. You could take the 35 out. You get 6, 2, 5, 8, 9. You could either go up to 63 or just don't bother. Take the 56. You get 6, 5, 8, 9, and then you take the 63. You get 2, 8, 9, and then 2 28 small of 7 and 9 has remainder 2. You could check it with the divisibility rule, which is 7 minus 412 plus 589. So it's 7 plus 177. So it's really just 100, right? So it's minus 5, which is 2, not 7, yeah? Okay, are we all good with that? So yeah, good. Thanks. Microphone check. And then I think you can keep going. So that means there's no solutions of this form, right? So case 2 has no solutions. Case 1 has no solutions. And I think I'll leave case 2 for you to do by yourselves. And if you want to kind of see if we had similar reasoning, you can look at the video from the Monday class. And you're all welcome to come to Monday classes and all the classes of equal or lesser difficulty interchangeably for the rest of this term, yeah? Okay, so we really need to make good use of our resources. And obviously the videos are available too. But the exam will be on the 9th of September, which doesn't give us too much time. But we're not trying to learn everything, yeah? We're trying to learn enough solidly so we can keep going for next time. A lot of the problems won't even be requiring you to know so much stuff. It's just that the future that we want to have requires us to know a bit more stuff. So this is question 10, okay? So you can see that question 10 is meant to be the hardest problem. It's not that scary. The reason the question might be considered the hardest problem is usually a combination of the proof aspect combined with the actual question. So in the actual test, I think usually question 8 or 9, question 8 could be considered the hardest, possibly, but you can guess it. So because you can guess it, it doesn't require a proof. I think the overall difficulty is less. Whereas for this question, there's no way you can get 5 marks without producing a proof of all the cases or like showing why whatever number you find is the only number. And so maybe question 10 is easier, for example, to get 1 mark or 2 marks than question 8. It's certainly harder to get it's certainly harder to get full marks than in question 10 than in question 8. I don't know if you guys know about there's like an investigation right after this.
Yeah.
So this is where you got to know the rules of the exam. The investigation is like, I think it's pretty much designed for people who are like, I don't know, like before not many people did Math Olympiad, so there would be people like already in the AIMO team, but they're just doing AIMO for the formality of it. And so it'd be kind of boring just to do the questions. You have like one question to think about for the time. So you don't waste it. But for most practical purposes, the investigation is not part of the test, okay? It's definitely interesting and fun to do, especially after the exam or reviewing it before the exam. But during the exam, I mean, I think you're better off just checking if your questions are right because it says bonus marks, but that's a scam, okay? They don't actually give you bonus marks. They I don't know if the rules are going to change, but at the moment they only award those bonus marks if you're tying for first or something, but I don't think they bother to do it anyway. So it's really quite a scam. But there's one hint in the investigation that's kind of interesting, is that usually if you come up with a good way to do question 10, like a good general way to do it, it works for the investigation as well to make a lot of progress. So oh yeah, can someone send Gavin the Discord link? Yeah, so yeah, so investigation is a scam during the exam, okay? But after the exam, I think it's fun. All right, Gavin, there's the link. But it does give you a hint as to the general how the question 10 can be done more generally. So if for example you look at like the set 3 homework question 10, that's an AI mode question 10 from the past. The style has changed quite a lot since then. That's why I've scattered all the questions up. Whereas like I think the later years are better to do as full exams. Yeah, so the investigation is there to maybe give you a hint about how to do question 10, what the generalization might look like, but the bonus points aren't. But the bonus points are definitely a scam. Okay, so you won't get any bonus points. I'm pretty sure I remember. I think Haibing did some of the investigation. Like he did more of the. It seemed like he did more of the investigation than the actual question 10, and he didn't get the points for it. So, but I kind of already warned this before that happened. But just the investigation just looked so easy that year, I guess. All right. Yeah, I guess it would be nice if it was like it was insurance points in case you lost like a couple of points here and there. You guys have any questions?